The ground wire must maintain continuity from its origin to the subpanel. According to the National Electrical Code, specifically regarding the grounding electrode conductor, a continuous path is mandatory from the service entrance to the main bonding jumper and all grounding points. Splicing or tapping into the grounding electrode conductor is not permissible. If the existing grounding electrode conductor isn't sufficient to reach the new subpanel location, it is essential to install a new, continuous conductor. The purpose of the grounding electrode conductor is to provide a low impedance path for fault current to return to the source, which facilitates the quick operation of overcurrent protective devices like circuit breakers or fuses, thereby minimizing the risk of electrical shock or fire. The National Electrical Code Section 250.24 addresses grounding service applied alternating current systems. It stipulates that the grounding electrode conductor connection should be made at any accessible point from the low end of the service drop or service lateral to and including the neutral bus within the service equipment or the grounded conductor, if the service equipment is installed outdoors. This ensures that the entire system is properly grounded from the point of origin. Furthermore, National Electrical Code Section 250.64 outlines the requirements for grounding electrode conductor installation. It emphasizes the need for secure and mechanically protected grounding electrode conductors. The conductor should be fastened to the surface on which it is carried. If exposed to physical damage, it must be installed in rigid metal conduit, intermediate metal conduit, rigid polyvinyl chloride conduit, reinforced thermosetting resin conduit, or electrical metallic tubing. Aluminum or copper grounding electrode conductors are permitted. The size of the grounding electrode conductor is determined by National Electrical Code Table 250.66, which correlates the size of the service entrance conductor with the required size of the grounding electrode conductor. For instance, if the service entrance conductors are 2/0 American wire gauge copper, the grounding electrode conductor must be at least number 4 American wire gauge copper. It's crucial to note that the grounding electrode conductor size is based on the size of the service entrance conductors, not the size of the subpanel feeder conductors. The grounding electrode conductor should be connected to a grounding electrode system, which may include a metal underground water pipe, a ground ring, or rod and pipe electrodes. When using a metal underground water pipe as a grounding electrode, it must be supplemented by an additional electrode, such as a ground rod or ground ring. This ensures redundancy and provides a more reliable grounding path. The National Electrical Code also addresses the connection of the grounding electrode conductor to the grounding electrode. Section 250.68 provides specific requirements for these connections. Connections must be made using listed grounding and bonding equipment, and the connection must be accessible. Exothermic welding is also an acceptable method for connecting the grounding electrode conductor to the grounding electrode. When installing a subpanel, it is essential to maintain the integrity of the grounding system. The subpanel requires its own equipment grounding conductor, which runs with the circuit conductors from the main panel to the subpanel. This equipment grounding conductor is separate from the neutral conductor in the subpanel. The neutral conductor and equipment grounding conductor are only bonded together at the service entrance. In the subpanel, the neutral and ground buses must be kept separate. This is to prevent neutral current from flowing on the equipment grounding conductors, which could create a shock hazard. National Electrical Code Section 250.30 addresses grounding requirements for separately derived systems, which includes subpanels. It specifies that the grounding electrode conductor for a separately derived system must be connected to the nearest available effectively grounded structural metal member of the structure, or to the nearest available effectively grounded water pipe. If neither of these options is available, other electrodes, as specified in National Electrical Code Section 250.52, may be used. The size of the equipment grounding conductor is determined by National Electrical Code Table 250.122, which correlates the size of the overcurrent protective device protecting the circuit with the required size of the equipment grounding conductor. For example, if the circuit is protected by a 60 amp breaker, the equipment grounding conductor must be at least number 10 American wire gauge copper. It's important to use the correct size equipment grounding conductor to ensure that it can safely carry fault current back to the source. While extending circuits to a new subpanel, it is not permissible to splice or extend the existing grounding conductor. Instead, a new, continuous equipment grounding conductor must be run from the main panel to the subpanel. This ensures that the equipment grounding conductor has a low impedance path to ground, which is essential for safety. The equipment grounding conductor should be installed in the same raceway or cable as the circuit conductors. This minimizes impedance and helps to ensure that fault current can quickly return to the source. The National Electrical Code provides specific requirements for the installation of equipment grounding conductors in various types of wiring methods. For example, when using non-metallic sheet cable, the equipment grounding conductor must be run within the cable assembly. When using conduit, the conduit itself can serve as the equipment grounding conductor, provided that all connections are made up tightly. It's also important to ensure that all metal enclosures are properly bonded together. This includes metal boxes, cabinets, and equipment frames. Bonding ensures that all metal parts are at the same potential, which minimizes the risk of electric shock. The National Electrical Code Section 250.96 addresses bonding of metal enclosures. It requires that metal enclosures be bonded together using bonding jumpers or other approved means. The size of the bonding jumpers is determined by National Electrical Code Table 250.102. When working with electrical systems, it is always important to follow the National Electrical Code and all applicable local codes. Electrical work should only be performed by qualified individuals who are familiar with electrical safety practices. Firstly, always disconnect power to the circuit before working on it. Secondly, use appropriate personal protective equipment, such as safety glasses and insulated gloves. Thirdly, double-check all connections to ensure that they are tight and secure. Fourthly, test the circuit after completing the work to ensure that it is functioning properly. Fifthly, if unsure, consult with a qualified electrician. Ignoring the ground wire continuity can lead to hazardous situations. For example, if a fault occurs and the ground wire is not properly connected, the fault current may not return to the source quickly enough to trip the circuit breaker. This can cause the metal parts of electrical equipment to become energized, which can create a shock hazard. Additionally, a faulty ground connection can interfere with the operation of sensitive electronic equipment. Electronic devices rely on a stable ground reference to function properly. If the ground is noisy or has high impedance, it can cause the device to malfunction or even be damaged. In summary, when installing a subpanel, it is essential to maintain the integrity of the grounding system. The equipment grounding conductor must be continuous from the main panel to the subpanel and should not be spliced or extended. The neutral and ground buses must be kept separate in the subpanel. Follow the National Electrical Code and all applicable local codes to ensure that the electrical system is safe and reliable. The grounding system is a critical safety component of any electrical installation. It provides a path for fault current to return to the source, which helps to protect people and equipment from electrical shock and fire. A properly installed and maintained grounding system is essential for electrical safety. Therefore, it is imperative to adhere to the National Electrical Code requirements and best practices for grounding when working with electrical systems. This includes ensuring that the grounding electrode conductor is continuous and properly sized, that all metal enclosures are bonded together, and that the equipment grounding conductor is run with the circuit conductors. These measures help to create a safe and reliable electrical system that protects people and property. When running a new circuit to a subpanel, select the appropriate wire size based on the ampacity requirements of the load. Consult National Electrical Code Table 310.16 for allowable ampacities of insulated conductors. Also, consider voltage drop, especially for long runs. A significant voltage drop can cause equipment to malfunction or operate inefficiently. The National Electrical Code recommends limiting voltage drop to no more than 3% for branch circuits and 5% for feeders. Use a voltage drop calculator to determine the appropriate wire size for the circuit. When terminating wires at the subpanel, use appropriate connectors and ensure that they are properly tightened. Loose connections can cause overheating and arcing, which can lead to fire. Use a torque screwdriver to tighten connectors to the manufacturer's specified torque. Label all circuits at the subpanel to identify the loads they serve. This will make it easier to troubleshoot problems in the future. Use a permanent marker or label maker to create clear and legible labels. Keep a record of all electrical work performed, including the date, description of the work, and materials used. This record can be helpful for future maintenance and troubleshooting. In addition to the grounding requirements, there are other National Electrical Code requirements that must be followed when installing a subpanel. These requirements cover topics such as overcurrent protection, wiring methods, and equipment clearances. Consult the National Electrical Code for complete information. The National Electrical Code is a comprehensive set of standards for electrical installations. It is updated every 3 years to reflect changes in technology and best practices. It's important to stay up to date on the latest edition of the National Electrical Code to ensure that all electrical work is performed safely and in compliance with applicable regulations. By adhering to these guidelines and consulting with qualified professionals, you can ensure the safe and effective installation of your subpanel, prioritizing safety and compliance with electrical codes.